Mechanism on formation of jet stream. The faster velocity of charged particles, the stronger a pinch effect of pulling each other, causing fast flow of winds concentrates in the center that forms a jet stream. The mechanism by which westerlies contain fast-running charged particles. The solar wind effects on the atmosphere of the Earth. The Sun emits solar wind amount of 1 million ton per second. The solar wind mainly composed of protons and it has speeds of 300 km per second to 900 km per second. The Earth and its atmosphere rotate counterclockwise direction. The Earth's thermosphere is composed of mainly protons. So, the solar wind acts on the atmosphere as shown in Fig. 1. Westerlies is blowing in mid-latitudes region. Protons H+ of solar wind touching through the east side of the Earth couple with the atmosphere due to an effect of parallel electric currents. However, the solar wind touching through the west side of the Earth is repelled by opposed atmospheric flows of the Earth. Overall, the atmosphere accompanying with charged particles in mid-latitude regions moves counterclockwise direction. Trade winds is blowing near the equator at day hemisphere. The solar wind rotates counterclockwise direction due to the Sun's rotation. The velocity of rotation is 1.89 km per second at surface of the Sun. At near the equator in the day hemisphere, the solar wind collides head-on with Earth's atmosphere, causing clockwise rotation of atmosphere from east to west by Geer's mechanism, and it generates the trade wind. However, the solar wind drives the atmosphere in a counterclockwise rotation at night as shown in Fig. 1. Magnetic energy associated with moving charged particles. Magnetic field H exhibits rotation of electric current. According to Stokes' theorem, the integral of rotation H is the line integral around the area, because adjacent H cancels out each other. When a magnet of m Weber rotates around current I, the energy change is given by mi joule, that is expressed by equation 2. Line differentiation of equation 2 along outer lines of the surface, we can obtain Ampere's law is described by equation 3. Interactions among running charged particles must be considered by the concept of quantum mechanics. The state transition is analyzed by the change of energy states in quantum mechanics. The changes of energy states due to rotational motion are described by the phase of the wave function. A Haranov-Bohm effect was demonstrated in an experiment where two electron beams, those are split from one beam, pass through the upper and lower region of the solenoid coil, result interference phenomenon by the difference of energies. In quantum mechanics, a rotating state is expressed by vector potential in the wave function. The energy of vector potential A on current J is given by equals minus inner product of vector J and vector A. Definition of vector potential A. The energy in a magnetic flux density B exerts on J is expressed by equation 4. Rotation of equation 4 is F equals cross product of vector J and vector B, which is Lorentz force. Here, relationship between magnetic flux B and vector potential A is defined by equation 5. Magnetic coupling among moving charged particles. Magnetic phenomena among charged particles are discussed by continuous currents. The relationship between electric current and magnetic field is usually dealt as continuous medium. Here, the phenomena of magnetic effects of running charged particles are discussed as continuum phenomenon. Charged particles running in parallel approaches each other due to lowering the energy. The magnetic flux density B2 generated by the current I2 on distance d is given by equation 6. The Lorentz force F1 acting on current I1 is given by equation 7. When two parallel currents becomes closer, the strength of the Lorentz force increases. The energy of Lorentz force F on running charged particles. The Lorentz force acting on the current J equals QV on a charged particle Q with velocity v in the field of E and B is generally expressed by equation 8. The cross product of vector v and vector b of the second term of Lorenz's equation 8 increases when the speed of charged particles is faster. And the term increases when the distance between them decreases. The charged particles running in parallel pull each other and will enter a state of low energy, which explains the pinch effect in charge particle accelerator. Conclusion. This video described magnetic coupling among fast-running charged particles using the concept of continuity, where assuming individual charged particles are linked continuously. The westerlies in middle latitude contains large amounts of solar wind of protons H+. These charged particles have various speeds, and the magnetic coupling energy between running charged particles increases as the parallel speed increases. As the result, high-speed charged particles concentrate at the center of the westerlies, forming a jet stream. Thank you for your attention.